All right, so number 2. A stationary block has 3 forces acting on it, a 20 Newton force to the right, a 15 Newton force downwards, and a third force R of unknown magnitude and direction as shown in the following diagram. What is the horizontal and vertical components of R? So what this problem is doing is actually walking you through how we work these problems. So we always start with a free body diagram. Your free body diagram is pretty much drawn for you. All right, so there's R. We show vectors with little arrows over them. This is 20 newtons, and this is 15 newtons. Okay? That's what that looks like. The next step is to always sum your forces in the x direction. In the x direction, I have 20 newtons. Actually, one of the first things we should do is always define our coordinate system. So here's the x, and it's positive, and there's y, and it's positive. You might have chose the opposite. I don't know. All right, so f of x is equal to 20 to the right, which is positive, minus r times cosine of theta, and it's going to the left. This whole thing is not moving, so it looks like that. So there's our first component. Well, actually, it says the horizontal and vertical components of r. So r cos theta is equal to 20 if I move everything over. So r in the x direction is equal to 20 over cosine of theta.
Why is it not equal, why isn't it negative r?
Because I moved this r over. Okay, so that is a great question, and I want everybody to hear this. When I originally did this, I said r was going to the left, and it was negative. Okay? What that means is that this equation that I wrote down is correct. Okay, it means that r is in fact going to the left. Okay, it means what if I guessed on r, I guessed right. Okay, and that may happen sometimes. So if I get a positive answer, it means that I did guess correctly. Okay, sum of forces in the y direction. Negative 15 plus r sine theta is equal to 0. R sine theta is equal to 15, and r in the y direction is 15 over sine of theta. Okay? Any questions about that? Actually, this shouldn't be ry. This is actually just plain old r, both of those. All right, so those are plain old r. So then the next question says, what is the magnitude of r? Well, if this is r and this is r, I should be able to combine those together. Okay, so r is equal to 20 over cos theta, and r is equal to 15 over sine theta. So that means 20 over cos theta is equal to 15 over sine theta. If I multiply this by sine theta, both sides, I get 20 times sine theta over cosine theta, and that is equal to 15. Yes? That is correct. So 20 tan theta is equal to 15. So tangent of theta is equal to 15 over 20. And if I plug in my handy dandy calculator, second tangent 15 divided by 20, I get 36.89. So theta is equal to 36.89. Do you guys remember how to get theta from that? Anybody remember how to get theta from that? Right. Inverse tangent, both sides. Okay? And you get 36.89. John keeps calling that arctan. That's another name for it. It's actually on some of the older AP tests, they call that arctan. So just understand that inverse tangent and arctan are the same thing. Usually in most of the newer things I've seen, they don't call it arctan, but it definitely is out there. And when you go to college, your professor might call it arctan or arcsine or whatever, but that just means that inverse. Okay, so be aware that that's out there. And so if he's helping you and he says arctan, that's what he's talking about, is that inverse tangent. Okay, so there's the angle. I accidentally worked C before B, but now that I know this angle, I can go into either one of this equation or this equation and plug it in. And so I get R is equal to 15 over sine of 36.89, and that equals 25. And there's probably a way of working this without using your calculator at all. That angle might be hard to find, but okay. Any questions on number 2? Number 3. A force of 37 newtons horizontally and a force of 5.9 at an angle of 43 act on a 4.5 kilogram block that is resting on a frictionless surface as shown in the diagram. What is the magnitude of the horizontal acceleration of the block? Okay, so start with a free body. And I have a force of 3.7. I have a force of 5.9. And I have an angle between the two of 43 degrees. They draw this for you basically. I also have a force of gravity, and I also have the normal force on there. So just to be completely accurate, I have those on there. All right, this force, 5.9, acts at an angle. So I want to know, what is that force? I'm going to label it F. What is that force in the x direction? And that's 5.9 times cosine of 43, which is 4.31. All right, so for this problem, the y doesn't matter as much, but since I want you to be able to do the same thing on every problem, we're going to work it out like you normally would. All right. So 5.9 times sine of 43 is 4.02. So the y of that one is 4.02. Now the way that I want you guys to get in the habit of working this, sum the forces in the y direction is going to be the normal pointing upwards, the mass times gravity pointing downwards, and the 4.02 pointing upwards. Is it moving in the y direction at all?
No.
No, so that's a 0.
We don't need that,
Right. Okay, so if we wanted to find normal, we would go with it. Okay, but let's see what we have. So sum of forces in the x direction is going to be 3.7 pointing to the right plus 4.31 pointing to the right, and it says it's accelerating, right? So it's equal to mass times acceleration. So 4.31, 8.01 is equal to 4.5 times A. So 4.5 divided by 4.5, I get A is equal to 1.78 meters per second. Okay, do y'all see the process is the same on every one of these problems?
Yeah.
You have a couple of questions you have to ask yourself each time. Like, is this going to move?
So it's like projectile motion, you just break it down.
Yes, that's right. Okay, do I need to work?
So we go to 5.
Yep.
What's
Okay.
the same?
All right, number 5. right, so number 5 says a force of 160 newtons pulls at an angle of 60 degrees on a crate that is sitting on a rough surface. The weight of the crate is 196 newtons. The force of friction is 80 newtons. These forces are shown in the diagram. So here is my diagram. It's 160 at 60 degrees. There's 196 newtons. See, they give these to you in forces already. And then 80 newtons. And then I've got my normal force. What is the magnitude of the normal force is what they're asking for. So let's break this one down. So 160, we'll call it force in the x, is 160 times cosine of 60, which comes out to 80 newtons. And then in the y direction, I get 160 times sine of 60, which is 80 times the square root of 3 newtons. Okay, that plug it into your calculator. You can get the decimal numbers. This is that sine of 60 and cosine of 60 you will memorize in pre-cal if you're in there. Okay, when y'all get to trig, like really into trig, y'all are going to be forced to memorize 30, 60, and 45 degrees. Yeah, the unit circle. So, all right. They want to know what's the normal force. Well, I'm going to go about this the same way. So, sum of forces in the x direction is equal to 80 minus 80. And that actually equals 0 here. It's not moving. Actually, none of it's moving, so it's all equal to 0. So 0 equals 0, that checks out. Okay, the next one, sum of forces in the y, which is where our normal force is located, is the normal minus 196 plus 80 square roots of 3, and that equals 0. So, let's see. If I move all this around, I get 196 minus 80 square roots of 3, so let's see what that is. $57.
So normal is gravity pushing down Mr. Berry, or
No, that's the weight.
the weight?
Normal is the force that table is pushing back
I thought
up.
weight was 196.
It is. That's the weight of it. It's 196 pointing downward.
Yes. What's in then?
Normal is it's on a table,
Okay.
and that's what the table is pushing up on it. It has to be something, or else it would be moving downward. Okay, so there's 5. Y'all want to look at 6.
Can you shoot it?
6 is the same problem, except letters. So are y'all okay with 6, or do I need to go over it?
No, I can do it.
Okay. All right.